Hello everyone and welcome to my channel. It's me Nissan Paudel, and uh, if you haven't yet subscribed to my channel, please do subscribe. So in this video I'm going to show you how to reduce a very complex network to a T network. This is a topic from electronics in MSc in physics. So if you are in first semester studying masters in physics, and especially if you are from True University, then you are more than welcome to subscribe to my channel, because I am going to post a lot of videos on many different topics in the coming days. So without any delay, let's get to the point and today's topic. So it's network transformation. So this is one of the most important uh, technique in electronics to transform a very complicated and very complex messiest network that you can ever imagine to a very simple network called T network. So let's I'll just show you some example. And so this box, uh, there are two, there are input. One represents the port for input, and two the port for load, where we keep load in a very complex network. So the cut and this box mm, represents a very complex network of resistors, inductors and capacitors that is possible. So we can reduce any type of such complex system into a very simple T network, where we just have to know three impedances: Z1, Z2 and Z3, right? So this is one, this is two, and this is one, this is two. This is where input is given, and instead of complex network, now we have this simple system of three impedances, and this is where load is kept. So what happens is the current passes through R1, through 1 to complex network, to 2 to load here, and back from load to negative terminal of 1. So and that's how every kind of network works. And now we just have to know the value of Z1, Z2 and Z3. And to derive Z1, Z2 and Z3, now let's define some terminologies. We define Z1 OC impedance of this complex network when the input is at 1, and 2 and 2, this 2 load is kept open circuit, open. So this is Z1 OC, right? So current passes through 1 through complex network without going to 2, it comes back to 1. So in that case, the impedance of this system is known as Z1 OC. And the next term is Z1SC. It's when 2 is short circuited. So what happens here is the current passes through 1 through complex network to 2, and through the short circuit to complex network to 1. The equivalent resistance in this case is denoted by equivalent impedance in this case is denoted by Z1SC. And similarly, if we interchange the load and input, if we keep input at 2 and load at 1, the equivalent impedance when 1 is kept open is Z2OC, and when equivalent impedance when 1 is short circuited is Z2SC. From these four values, we can now get the value of Z1, Z2, Z3. If we know the values of Z1OC, Z1SC, Z2OC and Z2SC, which can easily be done through experiments and using voltmeters and so on, right? So let's derive them. So the Z1OC, the theoretical value of Z1OC in this network is simply Z1 plus, since the 2 terminal is open, the current will pass through 1 to Z1 to Z3 back to 1. So the total impedance will be just Z1 plus Z3, and we'll write this as equation 1. And Z1SC, when 2 is short circuited, the total equivalent impedance will be Z1 plus Z3 parallel to Z2, right? Which is Z1 plus Z2 Z3 divided by Z2 plus Z3. So this is equation 2. Then we get Z2OC, which is again Z2 plus Z3, because one terminal 1 is open circuited, so the current will pass when input the source is placed at 2. The current will pass through Z2 to Z3 to back to 2, right? So this is equation 3, and you have Z2 SC, similar to equation 2, Z2 plus Z3 parallel Z1, which is Z2 plus Z1 Z3 by Z1 plus Z3. This is equation 4. So now we have 4 equations which we'll use to find the values of Z1, Z2 and Z3, so that we can convert it to pi network. So if you look carefully, there are just 3 variables, Z1, Z2 and Z3, for which we have to solve using these 4 equations. Obviously, one of them is equation, we can just omit one of them equation, one of those equation, and still get the values of Z1, Z2, Z3. And if we look carefully, the equation 1 and equation 3 are very similar, in a sense that Z1 plus Z3 and Z2 plus Z3. If we get the value of Z3, we can easily find from 1 and 3 the values of Z1 and Z2. So our main aim is to find the value of Z3, right? So if we subtract equation 2 from 1, we can eliminate Z1 and get the equation in terms of Z2 and Z3, which we can later use to find the value of Z3. So let's start by subtracting equation 2 from equation 1. So 1 minus 2 uh, is given by Z1 OC minus Z1 SC equals to Z3, 1 is subtracted, and Z2 Z3 minus Z2 Z3 by Z2 plus Z3, which will be Z2, I hope it's visible, Z2 Z3 plus Z3 square minus Z2 Z3 divided by Z2 plus Z3. So so we get the value of Z3. Z1 OC minus Z1 SC. If we look carefully, equation 3 is Z2 plus Z3, right? So we can replace this by Z2 OC and get the value of Z3 square in terms of Z1 OC, Z1 SC and Z2 OC. Or I'll directly write it, Z3 square equals to Z2 OC times Z1 OC minus Z1 SC, which gives Z3 to be root under, since its square will get 2 values, Z1OC minus Z1SC divide times Z2OC. This is the required Z3 impedance Z3 of T network, which we can use at equation 1 and equation 3 to find the value of Z1 and Z3. So Z1 equals to Z1OC minus Z3 equals to Z1OC minus Z3 is given by root under Z1OC minus Z1SC times Z2OC. It's plus minus, right? Which becomes Z1OC minus plus root under Z1OC minus Z1SC Z2OC. Similarly, using let's write this as equation 5. Equation 5. Similarly, using equation 5 in equation 3, we can find the value of Z2, right? Z2 equals to Z2OC minus Z3, which we will get as Z2OC minus plus, similar to this equation, root under Z1OC minus Z1SC times Z2OC. This way we converted a very complicated network to a very simple T network, right? So, and we get the whole values of Z1, Z2 and Z3. Remember that this will only work at a single frequency, because at a single frequency, because the impedance values will change if the frequency changes in inductor and capacitors, right? So for this video, this is all I'm going to explain. Maybe in the next video I will show you how to convert a complex network to pi network, and in the even next video I will show you how to convert pi network to T network and T network to pi network. And also in the many coming videos, I'll explain a lot more concepts in physics of MSc first semester. So please subscribe to my channel. Bye bye.